It's high time for grade 7 students, and these days we are talking about unit number 14, heat and temperature lesson. So this is today's plan. There are 4 subchapters to be completed in this under this lesson, and the measuring temperature section we have already completed, and thermometers, one part about the thermometers we discussed. And also today we will continue this chapter, thermometers, melting point, boiling point, and the clinical thermometers will be discussed today. That is today's plan. Let's move on to the first one, the melting point. We will explain that with an experiment. Let's watch the experiment. While watching the experiment, we can talk about this. So these are the things needed: ice cubes and a beaker, also a thermometer and the glass rod and the heating mantle or the heating equipment. Those are the things needed. The procedure is this. Look at the procedure. First of all, we will hang this thermometer on a stand, and as the beaker sink in the heating mantle now, thereafter we put ice cubes and we hope to melt the ice cubes and measure the temperature where the ice cubes are molten. So let's notice the temperature of the ice cubes when it is heating up. When ice cubes are melting, you can notice it. The temperature recorded as 0 degrees Celsius. So at 0 degrees Celsius, solid water or ice converts to liquid water. So this is the melting point. And melting point can be described as this: the temperature at which a substance goes from the solid state to the liquid state. And remember, substance goes from the solid to liquid state. The temperature, that temperature is the melting point. And melting point of water is 0 degrees Celsius. Right, let's move on to the next one, the boiling point. Again, we can watch that video. Let's play it and watch it. These are the materials required. For this one, we need distilled water, normal water, some porcelain chips to prevent overheating, and beaker, glass rod, and the tube and lid and boiling tube, also a region bottle. Then procedure is this: pour in some distilled water to the boiling tube, put in the marble chips into that. We must close this one with a rubber stopper to keep constant pressure inside it, and clipping it using a laboratory stand. And to go to the excess water, we fix this tube, and tube is keeping over the region bottle here. Now our task is to heat this up. There is a thermometer to measure the temperature change when water is boiling, and temperature rising up, you can see. Still it is not boiling. When heat continues to apply, it's boiling at certain temperature. Notice the temperature here. The temperature is 100 degrees Celsius. So liquid water converts to gas. The temperature at which substance goes from liquid to a gas is the boiling point. The boiling point of water, it is 100 degrees Celsius. That's what we can notice here. So it's very clear what is that melting point and boiling point. and melting points and boiling points of some substances. In short form, we call MP for melting point, BP for the boiling point. Let's see some substances. Substance, melting point and boiling point. First substance, alcohol. Melting point is minus 140 degrees Celsius and boiling point 78.4 degrees Celsius. Its melting point and boiling point both less than the water. This is water, 0 degrees Celsius and 100. We experimented and found that one. In mercury, it's higher than the melting point is minus value again, but it's very high. The boiling point is very high, higher than the water, 356.7 degrees Celsius. That means if you want to boil mercury, we have to heat to this temperature to convert the mercury to a gas. Next, wax. Its melting point also a high value. It's higher than the room temperature. That's why wax stay as a solid. Wax is a solid. At room temperature, it's a solid. But when you heat it to 47 degrees Celsius, it becomes liquid wax. If you heat it further 188 degrees Celsius, that becomes gas wax or wax vapor. Last one, lead. Look at the melting point, it's very high. Lead is a metal, it's a solid. If you want to melt lead, you have to heat it over 327.5 degrees Celsius. Or if you want to make lead to gas, you have to heat it to 1750 degrees Celsius. And these are the comparisons of this. And there is an activity here. By this activity, we can see how different liquids boil at different temperature. That is in the same hot plate here. You can see 3 different liquids on a hot plate. Oil. Second one is isopropyl alcohol or surgical spirit. And the third one, water. See which liquid boils first. And if you guess, if you go through the table here, it's faucet, and if you go through the table, you can see alcohol, water and oil is not given in the table. Let's see which has, the alcohol has lower boiling point here, and water the next, and what about the oil? Let's find this out. Right, it's heating up on a hot plate. As we thought, the alcohol now changing. You can see the liquid, first liquids to boil is the alcohol, because it has low boiling point. It heats up and boils first. Second would be, we can check the second one here. Check this out. Still alcohol, only alcohol is boiling here. It boils and vaporize. Its volume decreasing, you can notice it. Its volume decreasing here. And now notice water. The third beaker is then water. Water starts to boil up. That means the second liquid to boil is the water. Alcohol has the lowest boiling point out of that three. Then the water and oil has higher boiling point than both. Therefore, it is not given in the table, but now you can guess it. The boiling point of oil is more than water. This is a good experiment to see how boiling point works. Let's fast forward it a little bit. Okay. Now let's move on to the clinical thermometer, or the special thermometer type which is used in the medical purposes. This thermometer, it's used by the doctors, you know that. And also sometimes in our houses we use a clinical thermometer. For what we use clinical thermometer? Clinical thermometer is used to measure the body temperature. Therefore, this thermometer is a kind of special thermometer. Let's learn about the special features of this thermometer, clinical thermometer. First thing, there is a bulb as usually and mercury filled in the bulb. Also, there is an expansion chamber to fill excess liquid expanding here. And the scale is special. Lowest value you can see 35 and the highest value 42. In some clinical thermometers it is 43. Then lowest 35, highest 42. There is no 0 or 100 in this one. Why don't we need very low temperatures or very high temperatures? Because we use this thermometer to measure body temperature. Body temperature, if it goes below 35, that means the person is dead. Or if it's exceed 42, 43, the person will die. Then this is made to measure the temperature of living beings, not of the dead bodies. Therefore, it is made between this. What is the human body temperature or the correct body temperature? And we can find it hereafter. There is another special feature. I zoomed it out here. You can see there's small constriction here. Small bend in the capillary tube, a constriction. This is really important because when we measure the body temperature by keeping it on someone's body, and once we take it out, if the temperature, if the mercury level comes back, therefore the correct body temperature we can't take it. That's why there is a constriction. When this is expanded, once the temperature rise up, this constriction prevent it coming back. So we can take or read the thermometer accurately. If you want to take the mercury level back, you have to just shake that one as this liquid fills back into the bulb. So remember, there is a constriction in the clinical thermometer. Now the body temperature, we can check out the body temperature. Normal body temperature of the person, it's 37 degrees Celsius. If it is exceed or decrease, there is a matter. Then watch the gas constriction here. You can see the body temperature noticed here. This is the body temperature 37 degrees Celsius. And here is the range. The average or the normal range here 30, normal it's around 36.5 to 38.2. This range is normal in a person. But if it is increased or decreased, then there is something abnormal thing happening in the human body, and we have to take medications for that. Maybe fever or extreme cold. Then the range you have to remember 36.5 to 38.2 is the normal body temperature. Exact value is not the 37, actually 36.9 degrees Celsius is the exact body temperature of a human being. Right, with this we will end our lesson here, and you can find the or read the note from the blog site www.itssideTimeblogspot.com. Find the note and copy down the note to the tute. Our next lesson is about heat transfer methods. That would be the last lesson of this unit. If you enjoy this lesson or gain something from the lesson, press the like button of the video and also keep subscribe the channel to get the new videos. and to get notifications you have to press the bell icon as well. And we can meet back from the next lesson. Till that, goodbye everybody.